I wanted to go back to problem number 19, and the reason I wanted to go back to that is because I realized that on your review packets I actually fixed the problem, but in my flip chart I had not fixed the problem. Up here where it says R of T is in gallons, it originally said in gallons per hour, so that kind of messed up the problem. So on your review packet you'll notice that I actually got rid of the gallons per hour and I made it gallons. So the problem makes a lot more sense now. So we have chemicals that are leaking from a storage tank, and of course T is time, and that time is measured in hours, and R of T are the number of gallons that are leaking out of the storage tank. So this becomes a pretty easy problem. In part A we're looking for the average rate of change. Remember, A for algebra, A for average. In other words, it tells me to use simple slope, and I'm really looking at the slope of the secant line for the first 8 seconds. So I'm going to consider the initial amount that was leaking out and the amount that was leaking out at 8 seconds. So we're just going to do change in y, which would be 26 minus 40 over 8 minus 0, which gives me negative 14 over 8, which can be reduced to negative 7/4 gallons per hour. So this is a doable problem, and it's actually a pretty easy problem. It's really just considering and looking at the difference between average rate of change and instant rate of change. In letter B, they're looking for the instant rate of change, which we know is code for derivative, and we're trying to find the derivative at 4 seconds. Now, when we're looking at 4 seconds, remember that when we're in a table and we're trying to approximate the instant rate of change, we're going to borrow 1 point to the left and 1 point to the right, and we're going to approximate the instant rate of change using the average rate of change, which is again simple slope. So we would have 30 minus 38, that would be the change in the y, over 6 minus 2, which would be the change in x. So that would give me negative 8 over 4, which would be negative 2 gallons per hour. So that's really a pretty simple problem. Alright, let's take a look. We've already done number 20 in the last video. Let's take a look at problem number 21. We're looking for the equation of a tangent line. And so in number 21, if we're looking for the equation of line, we're going to start with the standard form of the equation of line. We know that it is at x equal to 3, so we have an x value of 3, and we need the corresponding y value by substituting in the 3. So that would give me, so when I substitute 3 into the equation, I'll get a y value of 2. So now I already know that I have y minus 2 is equal to, I don't know the slope yet, so I'll leave a space for that, x minus 3. Now the slope, of course, I need to find the derivative of the function. So y prime would be equal to 6x minus 10, and I need to find the derivative at 3, and so I'll substitute 3 into my derivative. 3 times 6 is 18. 18 take away 10 would be 8. So the derivative at 3 would be 8, so that's my slope. So my equation is y minus 2 equal to 8 times x minus 3. Now, since part of your exam is multiple choice, this could be in slope-intercept form where they distribute the 8 and move the 2 over, but that's not a big deal for you guys. Problem number 22, we're looking for the equation of the normal line. Now remember, normal line, normal is perpendicular to tangent. And if they're perpendicular, they have opposite reciprocal slopes. So I'm going to find the slope of the tangent line, and then I'm going to take the opposite reciprocal of that. The slope of the tangent line, I need to find the derivative. The derivative of cosine is negative sine of 5x times 5, because that's the chain rule. Derivative of the outside times the derivative of the inside. And I want to evaluate that at pi. So I get negative 5 sine of 5 pi. If you think of a unit circle, this would be 1 pi over here, 2 pi, 3 pi, 4 pi, 5 pi would be over here, and that is the y value. The y value of 5 pi would be 0. So y prime of pi is equal to 0. Now that's the slope of the tangent line. I need the slope of the normal line, which would be the opposite reciprocal. Now the opposite reciprocal of 0, if you flip 0, then the slope would be undefined. And we know, whoops, let's move my clock here. It won't move. Move. Okay, never mind. We know that if the slope is undefined, that implies that we have a vertical line. So what we're looking for is the equation of a vertical line, and the equation of a vertical line is x equal to a number. Well, we have our x equal to up here, so the equation of our line is x equal to pi. And then finally, number 23. Let me get rid of the stuff that I have on the screen. Come on, you can do it. There we go. In 23, we're trying to find the minimum of a product. So our product is already given. We're trying to minimize xy. That is the goal. Our helper equation is just simply given straight out to us. This really doesn't require a lot of reading. It's an optimization problem, but it doesn't require a whole lot of work from us. All we're going to do is substitute 4x minus 3 in place of y so that we have one variable. So the product would be x times 4x minus 3. So when we distribute that, we get 4x squared minus 3x. Since we're trying to find the minimum, we're going to find the first derivative and set it equal to 0. And if I set 8x minus 3 equal to 0, I get 3/8 as the value of x that would give the minimum. Now it asked me for the minimum value. Be careful, 3/8 is not the answer. So now to find the corresponding y value, I'm going to come in here, so I get y equal to 4 times 3/8 minus 3. So that would be 4 goes into 8 twice. 3 halves minus 3. Now remember, 3 is 6 halves. So 3 halves minus 6 halves would be negative 3 halves. So that's my y value and that's my x value, but I still haven't answered the question because it says what is the minimum value of the product. So now my product would be, we already know the product is xy. The value of x is 3/8 and the value of y is negative 3 halves. So when we multiply that together, we get a product of negative 9/16, and that's the minimum product. Now again, I can verify that this is the minimum product by finding the second derivative of my function, and the second derivative of 8x minus 3 would be 8. That's a positive value. So if the second derivative is positive at a critical number, then I know I have a local or a relative minimum. So that would be my support justification that I really do have a minimum. Hopefully I'll have time to finish this question, all these questions in the time remaining on this video. The function f is continuous and differentiable on negative 5 to 5 such that negative 5 is at negative 10, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, I think I miscounted, but you get the idea. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I have the point negative 5, negative 10, and I have the point up here 5, 10. Now I draw that graph so that I can look at the statements and try to make sense of what's going on. First of all, it says f, the function that's graphed here, isn't, even though we don't have an entire graph, we know that it's continuous, so there are no breaks, gaps, or holes, and we know there's a derivative everywhere, so there's no sharp turn, there's no cusps. F is an even function. Well, we know that has to be false, because if f were an even function, then the graph would fold over the y-axis. If anything, this function could possibly be odd because we have a reflection over the origin. So this is false. This function can't be even. Decide which of the following statements are always true, sometimes true, or false. This one's false. B says when x is 0, in other words, it's saying you have the point 0, 0 on your graph. Well, it's possible the graph could go through 0, 0, so I would say sometimes true, but not necessarily always true. F of c. Now understand when you're reading this, f of c is a y value. This is saying that there is a y value of 0 for some x value. This c is an x value. So somewhere between negative 5 and 5, what they're saying is that you would have to cross the x-axis. Well, of course, that's true. To go from negative 10 to positive 10, you have to go through 0. So C would be always true. Letter D says the derivative at a value of x is greater than 0. In other words, the derivative is greater than 0. And if the derivative is greater than 0, then we know we have an increasing function for all values between negative 5 and 5. So it's saying from down here to up here, we are increasing all the time. Well, that doesn't necessarily have to be true. It's not necessarily false. It could increase all the time, but it doesn't have to. So this would be sometimes true. Letter E. Now these are y values. This says that the y values stay between negative 10 and 10 the whole time. Well, that's not necessarily true, because it could be true, but it's not necessarily true, because the graph could go way above 10 and then come back down and hit it. So this would be, again, sometimes true. Okay, we're getting down to the nitty-gritty here. Letter F says the derivative is equal to 0. In other words, there's a critical number for at least one c between negative 5 and 5. Well, that could be true, but it doesn't have to be true, because if I drew a straight line to connect those 2 points, then the derivative would not be 0. So this would be sometimes true. The best way to work these is just to draw graphs that either refute or prove what's happening. G says the derivative is equal to 2 for at least one value between negative 5 and 5. Now this is a sneaky way to do the mean value theorem. If you actually find the slope 10 minus negative 10 over 5 minus negative 5, you get 20 over 10, which is 2. So that is the average rate of change. Well, the mean value theorem guarantees that at least once the average rate of change is equal to the instant radius change. So this was instantaneous rate of change, so this is always true. I've got 30 seconds. There is a y value of 9 somewhere between negative 5 and 5. Well, of course, that has to be true. If I'm going to get to 10, I have to go through 9. So this is always true. This is the end of the videos for the exam review. Do well. I know you can get an A or B, and I'll see you on exam day.